So, solving using substitution. Basically, last time we were subtracting or adding to cancel out terms to get rid of an x or a y, because we have to have a single variable to be able to solve it. This time we're doing the same basic idea, except instead of adding or subtracting, we're going to do some rearrangement. And that's something we did in the first algebra unit. So let's just look at a first example here. We've got a green and the blue again to make it easy for me to refer to it. So you've got two equations here. I'm going to choose the first one because it's got a single y. It doesn't matter which one you do first or second, okay? X or Y or whatever letters it is, A, B, C, all the way to Z. But if you have one which has a single variable, either positive 1x or negative 1x, it makes your life a lot easier. So there's no advantage to choosing a more challenging equation to rearrange first. So we're going to do the first one. We're going to get that 5x eliminated, so we're left with just y equals, making y the subject. So just like any other equation we're rearranging, we need to do the inverse. I want to get rid of this 5x. I'm going to subtract it from both sides, leaving me with a nice, simple, rearranged equation of y equals 21 minus 5x. Or, of course, if you prefer to put the x first, you could have y equals negative 5x plus 21. Once you've got this equation, anytime we see y, we can just put this in instead. And that looks something like this. We take the y here, which we now know is equal to 21 minus 5x, and we just put in the 21 minus 5x. So the y is no longer there, we only have x's. What we can see, if we just zoom in on this here, is now we can expand. We keep the 3x the same, but we need to expand the bracket. So we get 42 minus 10x. We combine all the like terms, so the 3x minus the 10x gives us negative 7x. Don't worry about that. We'll fix that negative in a minute. We then need to subtract the 42, and this will leave us with just negative 7x equals negative 21. Then, to get rid of the negative, we're going to divide both sides by the negative 7. If you don't like the negatives, use your calculator. X is equal to 3. Now, hopefully you remember doing the elimination method last week. Once we have a value of x or a value of y or whatever variables you're using, the steps after this point are exactly the same for any method you use. The only thing that ever changes is the first step. After that, it's substitute one variable, substitute the other variable, and check that they both work. So I'm just going to go through those a little quicker today because we have already been through those. If you're still not sure about this step, I'd advise going back to the first video, which breaks this down into slower steps. So, just like elimination, we're going to put y equals 6 in here, which if we put in 6, it gives us a nice, much more simple equation. We just now know that 5x, we take away the 6, is 5x must be worth 15, x is therefore worth, x is worth 3. Once we know x is 3 and y is 6, we put them both into the second equation. So we get 9 and 12 is equal to 21, which we can see works. So, as I said, exactly the same steps 2 and 3 as elimination method. Okay, let's look at a slightly different example now. So we might also see an example where we have a single value of x, but it's negative. Okay, still the best one to choose. Okay, it's better than choosing the ones with the 4 and the 3. All we need to do here, we take the equation, we're looking at that x, that's what we want to rearrange for, but we want to make it positive. So, simple solution, if we add just 1x to both sides, we're going to end up with just a 4y over here. That's going to give us 41, but we're going to end up with a positive x. We can then subtract 41 from both sides. X on its own is equal to 4y minus 41. And now we have that single x on its own. Last time we did y, this time we're doing x. It doesn't matter which one you choose. Once we've got that, we can, let's get another slide. We can substitute that in. We're doing the whole expression in a bracket to make sure that we don't miss anything. Really important that you're careful with your positives and negatives and that you substitute the whole thing. If we go back here, notice that I've done it in a bracket. Okay. So again, we're going to expand out the bracket, keep the 3y where it is. We get 12y minus 123. That's quite a large number, but that's okay. We combine the like terms, we get 15y minus 123 is 27. Add the 123 to both sides. If you don't like that, do it with the calculator. And then we can see that if 15y is 150, y is equal to 10. Again, done the first step, substitute y in, substitute x in, substitute them both at the same time to check. Same steps every time. So y is 10, that goes in. So we get 4 times 10 minus x is 41. Now here you've got to be careful because it looks a bit confusing. It says 40 minus x is 41. And you're thinking, well, 41 is bigger than 40. How is it getting larger when I'm subtracting? But make sure that you subtract 40 from both sides, okay, which should give you negative x is equal to 1, which means that positive x is equal to negative 1. Again, be careful with your positives and negatives. So most mistakes at this point when there's a negative value of x or y is people missing that step, and then everything after that goes wrong. So be careful with your positives and negatives. So putting both values in, we should, if it works properly, we should get 3. Obviously we've got 3 of each. We've got 10 here. We've got negative 1 here. We can just check that works. We've got 30 plus negative 3 equals 27, and we can see that that works. Okay, the final example I'm going to show you is very similar to the ones we've just done, but the numbers are slightly more awkward. We're going to look at one that involves fractions. So here, we're going to choose to rearrange because 2, 3, 5, and 7 have no common factors. Yesterday, we looked at upscaling, where you can multiply all of one equation by something so that it equals one of the others. If we go back to our example, we can see 2, 3, 5, and 7. You can't multiply 2 by any, well, you can, but it's awkward, or 3, you'd have to multiply it by 7/3. It doesn't make nice, even common factors. So this is a good example of when substitution is the best method to use. I'm not saying you have to use substitution, but it's the easier of the two methods for this example. So, in a similar way to upscaling, but kind of like downscaling, instead of multiplying to make them larger, I'm going to divide to make them smaller. If we look here, what I've done is said, well, let's divide everything by 2. It will give us a fraction, but that's okay. Okay, ignore that notification. It gives us y on its own, and then 3/2x, which we can subtract. We may end up with a fraction, but we've still got that y equals. So that means we can substitute that in. Now, when we substitute this in, this one looks a little bit confusing, so we'll just go through it in stages. I'm going to zoom in a little bit so it's easier to read. We put the whole bracket in here. Be careful, of course, with your fractions. When we do 5 times 3/2, it's going to give us 15/2. We multiply the numerator, not the denominator. We can then tidy that up by saying, well, 15/2 plus 7, 7 of course being 14 divided by 2, leaves us with just -1/2, which already is looking a lot tidier. Once we get to that point, we can subtract the 5 from both sides, leaving us with -1/6. And then -1/2 is -1/6, -1/2x is -1/6. If you don't like that fraction division, you can't do that mentally or quickly written out, don't forget you can use your calculator to help you, but you need to make sure that you're dividing -1/6 by -1/2. The two negatives cancel out, and then we simplify the 2/6 to get 1/3. Don't use the decimal. If you try and use the decimal, it will impact your other variable and you will get the answer wrong, even if just by a couple of hundredths or a couple of thousandths, so you must use the fraction. So now we can substitute x as a third. Obviously it goes in here. Nicely, because of course I've picked nice numbers. This question, 3/3 make a whole, and then subtract the 1 from both sides to give you just the 1 here, and then y is equal to a half. Don't forget to substitute both values in, and here I've made a common denominator to make checking the answer easier. So as you can see, for all of these methods, we'd need to get either a single x or a single y, making it the subject of the formula. And once you've done that, you can substitute it in and cancel out, leaving you with just either all x's or all y's. And then the steps after that, step 2 and 3, are exactly the same. Take one value, put it into the one equation, take both values, put it into the other equation. Very important to remember, just like elimination, you have to use both equations. So for example, if we just go back here, we rearrange to make y, the blue, which was the blue. We then put the rearranged blue into the green. We then took the value from the green and put it into the blue. Then we put both values into the green. So we have blue, so it goes like blue, green, first, second, first, second. Don't just do it all into the same equation, because then you're only proving one thing works, not simultaneous. So that's a basic introduction of how to use substitution method. If you want to go through any of those examples again, don't forget you can obviously replay this video. Also, the notes in the document I sent you in the first lesson and last lesson, and reshared again this lesson, have another couple of examples you can look through for substitution method. Once you're happy, go on to those 12 questions using substitution method each time. The quizzes are shorter today because this substitution method tends to take a bit longer to do. But don't forget, you only got those 12 questions to do, plus the quizzes, and you've got the whole lesson to do that. So do show your working and make sure it's very clear which equation you're rearranging. With the 12 questions in your book, obviously I would like to see the working out, but that's for your book. The quizzes is what I'm going to be kind of checking that you've understood on, and by getting the answers right, hopefully that's showing me that you understand what it is you should be doing.